All right, so thank you for joining us for this panel discussion with DevOps experts. We're going to be talking about managing complexity and adopting microservices. Thank you for the attendees that are joining us, streaming in right now. We are live on YouTube as well. And then I'm going to be introducing the panelists here very shortly. The first thing, order of business, introduce myself. I'm Jeremy Meese. I'm the head of DevRel here at Circle CI. Glad to be hosting this panel. And like I said, we'll be talking about managing complexity and adopting microservices. With the rise of microservices architecture and containers and all of these buzzwords that are out there, they've sped up development cycles for many. Managing them in production has created a new level of complexity. And so in this roundtable, we're going to be, discussing with our industry experts. We brought together for an enlightening discussion around kind of this evolution of microservices and the best practices or better practices for adopting them in your application. So without further ado, I'd like to start with the introduction. So from DeployHub, we have Tracy. Would you go ahead and introduce yourself?
Hey, yes. Thank you, Jeremy, and thank you to Circle CI for having this and hosting and inviting me. And my name is Tracy Ragan. I am the CEO of DeployHub. We do microservice configuration management across clusters. I'm also on the board of the CD Foundation, and I'm a DevOps Institute ambassador. So I'm really into this space, and I love microservices.
Great, thank you. Glad to have you. Joyce, Postman, you want to go ahead and introduce yourself?
Yeah, hi, I'm Joyce. I'm a developer advocate over at Postman, and I'm based in San Francisco. Last year, I gave a series of talks about how Postman engineering does microservices, and I have an update coming up soon. Also, Postman is a developer tool, and a lot of engineering teams use Postman, so I kind of get an inside peek at how they're struggling with their architecture.
All right, thank you. From Rollbar, Francesco, go ahead and tell us about yourself.
Yeah, thanks, Jeremy. And good morning, everyone. I'm Francesco. I run the engineering team here in Rollbar. And what we are trying to do basically is to help developers to, let's say, get a little more automation in the way we fix errors and in the way we discover errors. So Rollbar, what it does basically is automatically processing real time everything that is going on in your application. And it tells you in real time what basically is broken. So the aha moment generally that we like to see is when you see a software engineer very proud to push code in production. Now, all the tests are passing, all the greens all the lights are green. And then you get a message in Slack telling you that this line of code you just pushed to production is creating a problem for 1,000 users. And this is the content of variables that make that error happening. And seeing a software engineer that can actually fix the problem without reproducing it, that's generally something that we like to see. So we love microservices. We love also the monolithic applications because a lot of our customers are still using it and are still trying to migrate. And more than happy to chat about all the challenges that bring to an engineering team.
Perfect, that's good. Optimizely, we have Asa here.
Hey everyone, I'm Asa, developer advocate at Optimizely, and Optimizely is a progressive delivery and experimentation platform. So how can you roll out features gradually and experiment on those features to make sure you're building the right thing to begin with? What that means is Optimizely provides things like feature flags as a service, and a lot of my role is figuring out how to help teams implement feature flags as a service in either monolithic or microservice architectures. And microservice is a very interesting one when you think about feature flags that probably cross-cut your entire system.
Yeah, very true. That's good. Okay, so last but certainly not least, Angel from Circle CI here. Can you go ahead and introduce yourself?
Thanks, Jeremy. My name is Angel Rivera, developer advocate at Circle CI. And for those of you that don't know, Circle CI is a continuous integration, continuous delivery deployment platform that enables developers to build, test, and deploy their code using automation. Had to get the plug in, yeah.
That's right. Hey, appreciate it. Thank you very much. Okay, so microservices has been around. We've been talking about them, off and on now for quite a while. And before we get into that, I do want to also mention, if you have questions for the panelists, do not hesitate. Please use that Q&A function that is built into Zoom here, and we'll be able to see those and have some time towards the end that we can directly address those questions. So with the rise, we talk about the rise of microservices, but microservices have been around for a little while now. It's not this, but yet they still keep being a topic that we continuously bring up. And so why is the topic of microservices so important now, Francesco?
Yeah, so well, it's hard to give a single answer here, but I'll try to give my perspective. To me, it's evident that there is a change in the constraint. So microservices fix a specific problem, solve a very unique set of problems, and I feel like this set of problems became very relevant today. So back, I was thinking a few days ago, at the beginning of my career 20 years ago, you were building usually a Java application, is a big Java blob, and you sell that to run on-prem of some sort of big customers. You sell that to a company with 100,000 employees, and you feel fantastic. That's the best customer you can imagine. Fast forward 20 years later, 100,000 users, in a SaaS company, yeah, it's a good day, but it's not like the real business. And I feel like this is the new normal. So if you speak with a software engineer in 2020, the scalability challenges we are speaking about and we are trying to face are really about millions, billions of users, all at the same time, distributed globally. Mobile, cloud, these are all huge transformations that change the way we design systems. And usually when I speak with my team, I keep reminding to all the engineers in software engineering, everything is a trade-off. So the idea of best practice is always like, well, how long is going to be best? And I feel like has been a big transition, especially in the last 10 years, to a place where now monolithic architectures tends to have too much of a trade-off. It's really hard to scale them. It's really hard to maintain them. It's really hard to avoid this weird feeling of technical debt is everywhere. And sometimes it's just feeling. It's not necessarily that bad. It's just that it's really hard. And in the microservice world, this is kind of solved. And again, maybe 20 years ago was a niche. Not many companies have that needs. But right now, you just build a simple video game, you deploy it on iPhones and Android, and you need some sort of things in the cloud that makes the multiplayer working. And how do you build it? How do you scale that? How do you make sure that is sustainable and you can onboard engineers working on that? So again, to me, the short version of the answer is, the set of constraints change. And it's very unlikely that you can design something right now that is effective without it. And that's why I think there is this big rush to, let's get into microservices.
Yeah, I think, Francesco, so Postman Engineering is not even a super old company, but we didn't start off with microservices, and we actually started sniffing around it because yes, it's hot, but we had an issue with velocity and also scalability. You're probably talking about scaling to users, but for us, it was like, what engineers can make this fix now? So just restructuring some of our important functions allowed us to scale a little bit more. And then it's trade-offs, right? So we're like, ooh, microservices, and it's like, oh, and so it's kind of swinging constant.
I'd also like to
Yeah,
add
I'd also
that,
like, I'd go for it, Andrew.
Oh, no, go ahead, Asa.
All right. Yeah, I was going to say, speed as well as adapting to change. I like to think of it in analogies, and Francesco, when you said, the old system, you like deploy an on-prem solution. Microservices is like, okay, I deployed that computer, but now it's like that old PC where I can take the memory card and the CPU and the graphics card, and they're separate modules with clear interfaces that then I can upgrade and scale and adapt as the environment changes. And in today's world, the environment's changing constantly, even before a global pandemic. But I think that's kind of the benefit of these microservices.
Yeah, I was going to say, I'm old enough to remember waterfall, right? And how that kind of represented monolithic software development, right? Or that. So if you look at like where we are today, Agile came on the scene, maybe 20 years ago, 20-ish years ago now. And I was amazed that we didn't, in our software development lifecycle, actually reflect that in our code and in our architectures, right? Like it took a few years to kind of matriculate to where we are today. So to me, microservices kind of represents that whole transition from like that monolithic waterfall kind of development to where we are today. And it took a little bit of time for the industry to catch up with the agile, right, method of and reflect that in the architecture.
So I like the analogy a lot, because there is an aspect of microservices that, maybe it is a little controversial, but I feel like somehow is inevitable, exactly as agile. I remember the first time I went to my team, again, I was very young, very inexperienced, go to my team and say, hey, why we don't try extreme programming? And I remember that it was like an impossible journey. It was like, what, two people working on the same laptop in pair programming, they're gonna be half as productive, that sort of things. Like, we plan for next week instead of the next year. It was like, total sci-fi. And again, 20 years later is like, good luck in trying to build something in waterfall. Like, is really like, not an option anymore. You're never agile enough. And in some way, I feel like there is a parallel with microservices. Like, a lot of companies are struggling in adopting microservices. There is a lot of hard work to get there. So it's not exactly an easy green field you can walk into. At the same time, it's really hard to design something new today that is not in that space. So it's really becoming like, it's even hard to find talents not in that space. It's when I do interviews to hire engineers, and there is always a question like, how is your architecture? How does it work? And no one wants to drop the word monolith in that conversation. So there is this new feeling of, this is the way we build the complex systems today. And of course, it's not going to last forever, but at the same time, it's really hard to do something different.
Yeah, and I think that's a good transition into, like, Tracy, what's the fundamental difference between a microservice-based application and a monolithic application?
So I think that to really, there's been some talk about waterfall. I would challenge everybody that we are still doing waterfall. We still have dev, test, and prod. That has not changed. But if you think about, first of all, let's step back. A microservice we have to think about as a function. And a monolithic is a complete binary that has everything in it that it needs to execute. And if we look at how we develop that's the basic difference between monolithic and microservices. Now, in a monolithic style, we would take an entire binary, and we had a really smart person that would sit in the corner and figure out what to put in that binary. They would come up with what needs to be added to the compile, what linking we need to do, and we create a BOM report, so we saw everything that was in it, and we carefully took this piece and we moved it through the waterfall, dev, test, prod. That's monolithic development, and that's a monolithic application. When you think about containerizing an app and pushing it into a Kubernetes cluster, and you try to scale that up, you're scaling the entire binary. In microservices, you have a function. And instead of taking time at the beginning of our life cycle to compile and link all of those pieces together in a binary, we're pushing the functions alone. Now, microservices are not necessarily APIs. API developers may write microservices, but a microservice is more than just the code that's in it. It's the container, it's the SHA number, it is the Git commit that makes that particular container unique and pushed into a cluster. Now, when you do that, you wait until it runs and then you do the linkage through APIs. So what we did in the old days, building our monolithic at the very beginning of our life cycle, is now done at the end through a linkage step at runtime. And it can be different in every cluster. So while microservices have solved some problems in terms of everything that Francesco and all of you talked about in terms of the scalability, and it's critical that we have it. We can't write AI and ML and high performance computing cannot be done without it. It has changed and broken the way we develop software. And from a cultural standpoint, we all have to shift our thinking and understand the basic difference between what our monolithic did, our BOM reports, our diff reports, our impact analysis. That's all gone. Somehow we have to repair that because we've got to figure it out now in production. And most of the tools out there, they run it on a cluster. So now you got to go look at every single cluster to figure out what those dependencies are and those relationships are. So there's a big difference between writing monolithic and writing a microservice. And there's a lot of learning that we all have to do. And eventually we will get rid of waterfall because you'll have a cluster that runs dev, test, and prod, and it's all routed through service mesh. So we're getting there. We just haven't gotten there yet.
Yeah. So Tracy, do you think it's a deficiency in tooling or culture? You know, people kind of get wrapping their head around that, like what you just described, or is it all, or is it both? Like, because I have a sense that, yeah, I've been thinking the same thing for a while, and I think it's a little bit of both for me, but I'd like to know your thoughts on it.
Well, I think that we talk to people that are doing microservices and still deploying monolithic, right? They've got microservices are healthy running out there, but they redeploy them because they have to. And now we've got tons of versions of microservices we didn't need to. That's cultural. And it could be tool-based. We're new. We're just crawling. We haven't gotten up and started running in microservices yet. And most of the funding out there in terms of what's going into this particular segment, a lot of it has to do with managing the Kubernetes clusters. We're thinking about API gateways, managing what's running in the cluster and looking at what's running in the cluster. We still have yet to get to the point of maturity where we're starting to bubble that funding up and that and the technology coming up to think about it outside the cluster and think about what we're building as a whole and not dependent upon a particular cluster. So I think there's tooling and cultural things that we have to get over.
I think that's a good way of putting it. There is tooling and culture are very intertwined, and we've got to both have to grow together to really see a lot of those benefits. So, Joyce, what are some of the common pitfalls when we move? When people move to a microservices architecture, the different mistakes that were made. Like, give us some thoughts there.
This is it's like a really long talk that I gave last year, but if I just TLDR'd it, is it Sam Newman? Somebody called it distributed monolith. So this is something that Postman struggled with in transitioning to microservices. They were actually replicating not completely independent microservices. So they were just distributing the cost of computing across just exponentially. So that's something that is commonly known academically and in practice. And then I've also talked, Postman is kind of Postman engineering has swung up here with the microservices, and now they're like, oh, does everything need to be a new service? It's so easy to spin one up now. And I've talked to companies, very, very big companies that have hundreds, thousands of services, and they're like, it's so easy to do it. In fact, if somebody else is already doing it, it doesn't really matter. We'll just spin it up. And that's actually more efficient for them. So whether or not that's a pitfall or intentional, those are two probably some of the most common ones. What do you guys think? There's pitfalls galore.
I've heard some awesome new terms to describe this. My favorite is haunted graveyards, which is what you just described. When you have clusters that are growing and you're not sure why. And if you go try to bring them down, it's going to haunt you. And you have Frankenstein clusters. I like the Frankenstein cluster image too, because that's a cluster that's growing and growing and growing, and you're not sure why. So I think what you just described is a pretty common problem. But I think it's sort of like when fools rush in, you just start building microservices. I think one of the biggest mistakes that people make is not stepping back and really sorting out a proper domain-driven design for building out your microservices. What are the patterns of your organization? Can you look at a few of your applications, decompose a few of those applications, and start recognizing the different patterns of microservices, and then organize them based on domains and start thinking about them and sharing them in terms of domains? So what instead happens is all the teams start writing microservices, but there's no reuse. And that isn't useful either. In order to really achieve the agility that businesses are trying to achieve with microservices, the reuse is critical. And without that domain structure and a way to see it and a way to understand your organizational patterns, you just end up with a lot of microservices, and you end up with graveyards and Frankenstein clusters.
Yeah,
I like those two terms.
yeah. So I like it too, and also I feel like in my mind there are two categories. I would say there are many, but two categories of let's say company, teams, groups. Now I definitely see a lot, like fresh teams, new startups, or freshly built team in a big company, and where the idea is that we need to build something new that doesn't exist, so we build it starting with microservices. And usually when you get down this route, you don't know exactly how to cut, and you end up cutting in the wrong way the services. You always end up with a fantastic architecture that is not the one that really fulfills the needs of the application you're building. Or you have the other side, that are companies that have a business model very clear, that maybe is running for a few decades. And these companies want to move into microservices, but they have a huge monolith that they drag along, and that's where you start having the distributed monolith, like the haunted graveyard. Those two groups tends to, in my mind, end up with different issues in try to get to microservices. So again, the example we heard, the distributed monolith, that's very common. Like you take a big thing, you try to cut it somehow, you deploy in different ways, you pretend is microservices, and it generally gives you some benefits, but I think it takes no long to actually see the issue with that. It's really like it most of the time brings the worst of the two worlds. So you get the problem of distribution that you have in the microservices, so it's hard to centralize, and it's hard to have a central point of action. And at the same time, you can't change quickly, a part of code, because everything else breaks. So you don't have enough isolation. So this is where I feel like it's challenging. My few kind of memories I always bring with me about scars from the past. Like everything that needs to be centralized needs to be decided very early in microservices. Now I've been working with companies with like thousands of microservices, and they're still in trouble in introducing an APM tool, because you need to add the same tool on all the 1,000 microservices. Is one line of code. It's just since you have 1,000 microservices, you need to add 1,000 line of code. Probably you need to speak with 1,000 different people, and this is a 2 years long project. And again, it's the same line of code with the same access token, then it's the cut and paste on 1,000 different repositories. And until this line is everywhere, you don't get the benefit of this tool, because this observability tool, lacks some information, so you can't trace what's happening in your network. And so again, everything that is defined across microservices requires strong architecture leadership, and needs to be decided early on. Otherwise, it's really hard to change it later. Authentication is another example. Logging is another example.
Yeah. So oh, go ahead, Angel.
I was going to say, a lot of the problems that we have with microservices, I think we've had them forever. And I think they're rooted in the fact that we as developers and operations folks, mainly developers, are more focused on the applications, the languages, making our jobs easier, but we're never really truly invested in the data, and we treat it like a third-class citizen, right? And we don't model the data properly, or we don't spend, in my opinion, we don't spend a lot of time there. And that's the most important bit of what we do as a business, as a community, right? So yeah, I'd just like to say that, you're never really going to fully solve these problems. That's unrealistic. But I think if we lend a little bit more attention to data and the importance of it, might help us with future us, and engaging microservices.
Yeah, that's good. That's good. So Asa, walk me through or walk us through some of the optimal solutions for, some of those problems that we've talked about and kind of the benefits to solving them.
Yeah, I might answer more with these principles that have sort of already been shared. Tracy mentioned, really thinking about the context of your organization and your product to get domain-driven areas. I'd also add, thinking about how your application is going to get used. Are there pieces that you expect are going to have to change or going to have to scale? Or are there other aspects of your application that have to step in lockstep? And maybe these can help you, cut those pieces as best as you can to begin with. Like Angel said, the first cut's probably not going to be right, but you got to make your best effort. And then, to Francesco's point of if you're noticing, every service needs the same line of code or same piece of functionality, is that kind of a code smell that itself could be its own service in service to these other services? We see that with feature flags. A lot of times each service wants its own feature flags, but in some cases you need feature flags that cut across all of them. So, Optimizely has recently decided to, put Optimizely as a service that you can deploy among your microservices to kind of provide feature flags. And it's just interesting how you can take these different problems and cut them different ways, and just sort of understanding what are the options and what are the pros and cons of each.
Well said. Well said.
Jeremy, I think you're muted.
So Angel, we have APIs and in microservices. So how are they different?
Oh, you don't want me to answer this. No, I'm just kidding. So
I do.
I'll try to explain it the way that I use this analogy quite often with folks who are either starting out. Like I used to do tons of work at hackathons and mentoring and judging. So, you have some really young developers that are just starting out. And I always, I would get this question often actually. And I use the analogy of, I look at it, the difference between API and microservices, just like Tracy said, right? Microservices are basically exposed functions, but the API, if you go to your doctor's office, right, when you kind of go through that foyer and you check in, the API kind of serves as that gateway, right, to the doctor or the services that you're going to get. So, you would use an API to go ahead and authenticate, right, and then that request would be pushed back to somewhere to give them your ID. You sign in, right? So it's a gateway. It's just a layer that's included with the microservice. But again, right, it serves as, again, a more of a router in a sense, right? So you can get to the proper places or the proper functions that you want, the proper data. So I don't know if that analogy works, but I just like to use that doctor office kind of feel, because it does have things like authentication, right? You make sure this is the patient you're going to see and give services to, make sure that that you're actually providing the proper services.
Okay.
Sorry.
No, anyone else have anything they want to add to that?
I think that doctor's office analogy is awesome. I mean, I usually try to say, no, API is like the linkage and the microservice is a function, but I don't think it works as well as the doctor's office description.
That is a really good one.
It kind of resonates though.
Yeah, I mean, also, I feel like we have some experience with microservices now. Like the industry has been doing this for a while now. So, it's not exactly that we haven't learned a lot of things. So this is where again, 10 years ago, you're playing with microservices, you might have ideas of what might work better or not. And again, the first take is never really correct. But right now, for example, we know that in a microservice architecture, it's very likely that you want an API gateway. It's very likely that you want authentication done at that layer and not in other layers. So, it becomes more easy, I think, to not doing the same mistakes or try to reinvent the wheel once again. So, I see why, the two terms needs to come up at the same time in a discussion, because if you do have a microservice architecture, it's very likely that you're going to be really serious in the way you design APIs and you take developer experience as a real first-class kind of experience when they're public, but also when they are internal. And one of the, I know it's really hard to achieve. I know not many companies do that, but I still love when I see applications built on microservices, and maybe there's a web interface to use this, and you inspect in your browser that application and you see the calls. So you see the routing of the calls to the internal microservices. You see how the dynamic works and is presented to the user. So the fact that internal APIs and external APIs are the same, that I think is some of the kind of nirvana of the microservice architecture. Not that popular right now, I have to say. But again, we have years of experience now on these, and it's not that hard to find some of the best or better practices on this.
Also, as applications get more distributed, or services, I should say, right, those API layers are going to be even more important, because again, how are you going to interface, right, with these functions? And then I predict we're going to see API level kind of microservices, right? That kind of consolidate a lot of the same functionality, and they'll be their own thing that'll attach to some microservice. I don't know. I have a feeling I'm already starting to see a couple projects that are going down that road.
Yeah. Okay. So, Tracy, what changes are required to support microservices across the whole CD pipeline?
Oh, well, let's take the steps. So if we think about continuous integration and continuous delivery, we'll start with continuous integration. What was the point of continuous integration? Check in and compile, 10-minute builds, right? That goes away. So the whole point of what we did CI for actually is going to be diminished, because we don't necessarily have long builds in the first place. Python is interpreted, your build's going to be registering, running a Docker command and registering your container, it's your build. And even if you go back, even before the CDP, the build part, if you just think about version control, if you're not writing a piece of code that's 3,000 lines long, you don't need so much branching and merging, because you don't have multiple developers working on it. So the whole idea of branching and merging your code goes away with microservices. So those are two pretty big pieces of the CD pipeline that will be diminished in ways because of microservices. Now, the workflows themselves, we right now generally have, depending on what tool you're using, you have a job or a workflow that usually manages one monolithic application. And a monolithic application generally has one repository. So you have a repository, you check in, check out, compile, push it through push the binaries through the workflow to the release. Now with microservices, you're going to have lots of little workflows, because you have most people are doing one repository per microservice, which means it's independently deployable, which changes everything. And that gets pushed through its own workflow. So now instead of having one big workflow for your application, you're going to have lots of little workflows. And then each one of those gets pushed out. Now, an application becomes a collection of microservices, and you as an application developer may not have even written some of those microservices. So you could have a situation where a microservice gets changed and suddenly your application stops working, and you have no idea why, because the way you would have figured out before is you would have said, do we have let me see the BOM report and let's do a diff report so I can see what's different between today or 5 minutes ago and right now. So all of that is creating the CD pipeline to wobble. And it's wobbling kind of right now, it's wobbling to a point that it's hard to aggregate that information. So what we're going to be seeing is the CD pipeline is going to have different tooling in it. Again, the build's going to have like a, you know, you're going to have a build that's basically creating a container and registering it. You're going to have lots of workflows. We're going to have ways to aggregate that information, and we're going to have ways to start tracking a logical view of an application. Because all of that goes away in a microservice environment, and the tools that we're used to using to put those pieces back together are gone.
One of the questions I get asked all the time is, how do you make sure you're not breaking other people's stuff? Like, you're a microservice, you're so free, you're so independent. How do you make sure that your changes aren't breaking somebody else's stuff? So like Postman engineering, we do consumer-driven contract tests. So the consumers of the provider service will actually write those tests and then plop them into the pipeline of the producer so that they have to pass all those tests. That's like real tactical, but that's,
yeah, see, that's a huge change, right? That's a huge difference in the way we think about testing in general. It's a huge shift.
Also, it's, to be fair, worthless, right? Because if something's broken and you have these tests, they're only going to tell you it's broken, right? what's the fix? Unless the provider's on top of it, which happens all the time, right? Like I'm not going to name any names, but it happens all the time right now because of the dependencies that we have, right? Some of our services rely on other providers, and some of them are microservices.
But if you write if you write the tests, like if the consumer is writing the test, you're saying, I'm only using this thing and I expect it to be like this. Then when something fails, it's like, this is what broke it. It's very easy to follow.
Oh, no. I get that part. But what I'm saying is, what's going to prevent it from breaking? You know, I get the test. That's just a tool to debug. But there's other, like what we were talking about earlier, you know, your dependency now on these services, and you know, it's another SLA.
That's why we focus so
topic,
much. Yeah, that's why we're focused so much on configuration management. It's got to be put back into the puzzle. It can't be just left out because we're not doing a build anymore. You have to be able to say, if I've got a microservice that's going to impact 5 different applications, I need to know that. And the CD pipeline needs to be smart enough to say, don't push this through fast. We have to somehow notify those other consumers that a change is on its way and be sure and test it. So it's just going to look different. I think we're going to see smarter CD pipelines. I think that we're going to be able to start pushing information back, and the CD pipeline is going to know when those kinds of tests need to be executed. They won't be so static.
So I'll like to take a little bit of a moment of like proud almost. So just hearing, for example, contract testing. Now, contract testing, I think, are a fantastic way to basically, you know, have gentleman agreements between microservices. Like, I'm not going to break that microservice because I put a test in there that validates what I'm doing. But I feel like the industry moved in a very good directions there. You know, contract testing, you know, are replacing basically, you know, spreadsheet with, you know, documentation about how we should do things. You know, and that is testing, is code that runs, can be debugged, can be, you know, can be audited, can be traced. You know, another change that I definitely see in companies running microservices, you know, pull request. If I make a pull request and I submit the pull request to a team to merge it, you know, that is not just, hey, I wrote some code, no, please review that code. That usually is an agreement to accept ownership. Like, I wrote this code, but you are the owner of the thing. You know, that's your service. So you have the responsibility of merging it, and you have the responsibility of, you know, make sure that this thing is not breaking anything else. So this is shifting a little bit the perception of the tools we have. Now, again, my engineering mindset feels extremely happy to see engineers writing contract tests instead of writing Excel files telling other people what to do or what not to do. It's way more effective as a tool. And this is part of, I think, of the reason why a lot of organizations are looking for microservices, not necessarily for the scaling and technical reasons, but for the cultural benefits that this implies. Now, you start removing a lot of writing documents that no one reads and no one updates. So there is always a document telling you what to do and the fact that you did something wrong, but no one is telling you what to do to prevent that to happen. And now we are replacing these with tools that are way more effective in that. And usually they're written in code. So, engineers also love to use those tools.
But that brings another, I guess, a pain point that I think we're going to get to where, like, yeah, we're decomposing monoliths into these services, but we're versioning them, right? So, and you can't just stop like 3 versions back because of this, contract that we have with other services. So at what point do we get to the point where we're going, I guess, horizontally, right? Instead of vertically like before. So, right, I think you're going to end up in the same kind of boat a couple of years from now, because you're not going to disable services because people don't want to I know when APIs change, I leave it to the last minute because, it's a lot of work to, conform to this new version, and then they're sunsetting things, right? So, like, I think there's a deeper kind of problem with all of this, not just microservices, right? Like software development in general.
Yeah, I think what we're talking about is something that we could probably call microservices DevOps. It's different. DevOps is different from a monolithic process is totally different. DevOps is totally different than microservices. And we have so much yet to learn and so much collaboration to do and working together to get this stuff solved. Because every piece of the puzzle has to be reconfigured, basically, to use my term, configuration. Everything has to be reconfigured. How we do testing, how we have these contracts, how we track dependencies, how we deploy, how we build. Every bit of the CD pipeline is morphing big time.
That sounds like a great, like a whole other big roundtable discussion just on that itself. I think I think you make a really good point. Asa, did you have something to add there?
Yeah, I mean, I was just going to ask the group, how important do you all think it is for consistency between how these microservices are deployed? I think sometimes microservices, it's really nice that a team can choose the tools that for testing, deployment, observability that matter, best for that microservices functionality. But in terms of an organization, when you're talking about one team adding tests on another microservice, or, being able to have, easily jump on another team, maybe from Circle CI's perspective, if all the microservices are on Circle CI, that brings a lot of benefit to the organization.
Well, I think standards is super important. I'm sorry, Angel.
No, I was just making a snarky comment.
Well, I was going to say, I think standardization of the deployment of the microservices right now is pretty critical, because if, like, I spoke to a customer this week, and they have 70 clusters, and they're having to deploy to all 70 of those clusters. Now, if everybody writes their own Helm chart to deploy that, it's going to be a problem. So yeah, standardization of the deployments is pretty critical. I mean, that's just one tiny little piece of the problem, but standardizing how that stuff is done is going to be important. It's part of automation, and we can't do this stuff manually.
Yeah. So I think that's a good little segue here. We have a number of questions that I'd really like to get to here. So what I'm going to do with the Q&A, I'll read the question, and then have somebody from the panel will go ahead and raise their hand or wave or whatever they need to do to claim that answer, and you just answer that, and then we'll move to the next one. That way we can kind of get through as many of these as possible. So I'm gonna start with let's see here. So Calvin asks, says that you refer to a service as an API that maintains a contract which consumers can use. It's not much different than providing a SaaS product to customers. You provide documented APIs, which shouldn't break for customers every time you make a change. So what are some examples of ways you have managed and governed services within your organizations? Do project managers coordinate with other PMs off in their own world? And is this inter-organization billing between service providers and consumers like you would do with users of your organization's products? Who wants to take that one?
I can
All
start.
right, Francesco.
Well, my impression, I use the word impression, is that traditional project management is not always covering the full needs. That's why I feel like it's important for engineering teams to find a way to align on those. Now, just the question we heard a few minutes ago, what do you do with your like CI/CD pipeline? Is one pipeline for everyone that is forced down by the architect, or each team, each group is doing something different? It's common that different groups will end up with different workflows. And in my mind, again, in my opinion, traditional project management doesn't necessarily align that. You need a very strong engineering culture to make that working. So the other example of contract testing, that is way more effective, in my opinion, than most of the project management techniques I've seen to guarantee that a team is not breaking a contract with another team. And this needs to come from engineering mindset. There is no way around. There is not a Jira ticket that will avoid you to break someone else's microservice, and down the route, basically you take down the application. You need to do that with code at the end. And so this brings the responsibility of the engineering team, one layer up, in my mind.
Got it. Okay. Let's see here. So, Juan Carlos says, how do you keep traceability info between microservices and apps? Go ahead, Tracy.
So I've asked this question many times. Some people say they do it in their head. Some people say they do it in an Excel spreadsheet. Sometimes it's tracked in your Kubernetes deployment file or your Helm chart. But I'm going to make a plug for an open source project that we're working on called Ortelius. Ortelius.io is an open source project that we're working to solve this problem based on doing based on a backend relational database that we can start tracking it. So it's not an easy solution to solve, and maybe keeping it in a Helm chart or in a Kubernetes file and using GitOps to solve that problem is a good way to do it now. But as microservices grow and clusters grow and we get more clusters, I think we're going to have to have a more sophisticated way. So, if you're interested in helping out, Ortelius.io. It's a mapping solution.
Cool. Yeah, thank you. We have one question here that it's a noob question. He identifies it as a noob question, but as I look through here, I think it's not so much a noob question. So Troy said that he has a couple questions. As you work to separate your code into functions and microservices within a pre-existing architecture, at what point are you able to identify if you have done too much or if you can implement more? And then the second question out of that is, once you separate different functions from the main code, he would guess that there would be more of a chance for vulnerabilities. And is that a true statement? So who wants to take maybe the first one or both?
I'll take the first one.
Okay.
I think as you start to split out systems, I think there's added cost of, okay, now I have a new thing I need to deploy and need to manage. And at some point, if you keep splitting these things up, the cost of deploying and managing each one is just going to outweigh splitting up to begin with. So I think there is definitely a fuzzy line. It's not very exact, but a fuzzy line where the cost of splitting outweighs the benefit.
Yeah, I think that just to piggyback on what you said, Asa, I think the approach I've been bit in the butt just by doing exactly what you're describing, Troy. So one of the approaches I learned really quickly was, all right, we need to stop. Like Tracy said, I believe earlier, figure out all the common patterns and consolidate those into a, seamless kind of function that will provide the data that we're looking for in the manner that we're trying to get, to process it. So yeah, definitely take the approach of trying to find the similar patterns and then consolidate those into a function that can produce the results you're looking for sure.
Also, in my mind, to make a joke here, look, it's like the ropes. Ropes come in two sizes, too long or too short. You can only have one of the two. And I think microservices, goes in the same way. Like you can't have a perfect size, the split. It's never going to happen. You're always going to end up with either too many, too small, or one that becomes, you have a lot of microservices, but one of them is really big. This is common, and I feel like over-optimizing those might be actually not that productive. So again, because there is a company around these microservices try to make money and grow and fight competitors. So it's not exactly that this is happening while happily we are trying different things. So a point of balance is generally impossible to find. You're always going to be too much on one side, too much on the other side. What I like to do in my organization is basically, instead of trying to find the sweet spot, is basically when you're too much on one side, try to swing on the other side. And when you feel you're too much on the other side, try to swing back. And this creates this constant change where, there is a lot of energy because you do something different than before. And generally you tackle the main problems you had first. So you never reach the balance, but you keep oscillating between the two. But I would like also to jump in on the second question about, does this add more vulnerabilities? Because this is a common question, I think, in microservices. And I feel like it's a controversial one because, I almost feel like the industry, is pushing for an answer that is security is independent of architecture in this case. You can have very secure monolithic application and very secure microservice applications, but I would like to take a different approach. That is, I think microservice architectures tends to be way more secure than monolithic. And this is from, but my very personal experience with software architectures. And the reason is because I believe ultimately software engineering teams tend to follow the path of minimum resistance when they build something. So when there is an architecture you need to build, you're going to build it in a way that consumes less energy. So whatever it takes to get there with less energy, you're going to do that. And so in monolithic applications, security tends to be very much about analyzing the application because it's more effective. It's much easier to just take one repository, scan the hell out of that repository and try to understand through static analysis and a bunch of different tools if something is not safe. Microservice is really hard to do that, extremely hard. It's much easier to just, again, put an API gateway that does, play around with a JWT token. Maybe it inject, some other tokens for encryption down the line. Now suddenly you have this nice split of concern. You have someone that is working on authentication, someone that is working on encryption, someone that is actually playing with the real data. And these three people don't know each other, they don't speak with each other, and becomes a little more challenging to introduce an issue that potentially is catastrophic. In monolithic applications, I saw amazing design about security, and all the time, again, it takes just the wrong line of code to basically just accidentally broadcast to everyone all the tokens, all the encryption keys, and so I think it's controversial. I don't think it's safe to say microservice architecture tends to be more secure. But in today's time, with all the best practices we have, with all the learnings we have, I think it's more likely that you accidentally build a safe application when you do microservices.
Cool.
Could it be that those things are contributed to the fact that it's distributed, right? So, you're going with like role-based access controls, right? And more refined kind of privileging on the back end. So like if you have an authentication authorization microservice, right? All your other services will call back and gain, get the information they need or the access they need via this. But if you have one, like you were saying, one central kind of point of failure, right, to an attack vector versus, because the data, who cares if if it's encrypted and they can't get the data sets from those other services, doesn't matter.
Absolutely. And again, in monolithic application is, one of the things that always puzzled me in my career was always seeing monolithic applications dealing with encryption keys. because generally the line of code that fetch the key is just before the line of code that use the key to decrypt data. And it's always like, where's safety in that? So microservices tends to accidentally, not really driving you, but if you don't pay a lot of attention, generally it tends to have a better design around security topics. And again, it's not a safe thing. You need to pay a little bit of attention and, please, follow some good practices around that.
Cool.
Oh, I could
All
build
right,
some
so that's
insecure microservices.
Just give
I
them
mean,
time.
Don't worry about that.
All right, so thank you very much. That puts us to the end of our time here. I will want to, again, thank each of the panelists that have been here. Thank the attendees, and there's a few questions yet that we still haven't addressed yet that we'll start to compile and see about putting those, disseminating those in some ways. That way we can get some of those answers back out. But I thank each one of the panelists for being here. Yeah, thank you.
Thank you. Thank you to everybody. It was great.
Bye.
Enjoyed it.
Thank you.
Thank you.
Anna.